Hello guys, welcome back to Maths on African Motives. We are still on our analytical geometry working. Actually, this is the introduction that we're going to actually have, working with the line segment and so forth, on calculating the distance, or which is the length of a certain line segment that might be given. Remember, this whole part of our analytical geometry, it is centered on points that lie on a Cartesian plane. The Cartesian plane, the one that shows us about the x and the y, that is the one that we refer to as our Cartesian plane. So like I said, all this that we are talking about, it is centered on this Cartesian plane. From the origin of the Cartesian plane, we can have any point that can be taken, which is represented in terms of x and y. A point, whenever you see a point, that is A is a point, the coordinates of this point, we've got the x coordinate and we also have the y coordinate. So together they build up a point. They give us what we refer to as a point. So we are referring to point A. Point A given with the 5, 2 like this, 5s to 2 like this. It means we've got the x value, the y value, the x value there, it's 5. The y value there, it's a 2. That's a point, a point. So when you are now talking about the length, which is the distance that is found between 2 points, because these 2 points, when they are there is A, there is B here. When you join them, they form a line. So definitely the moment that we have formed a line, we want to know the distance, the length of this line. That is the distance or the length that we have between 2 points. All right. Taking a consideration that we've got 2 points, the point A represented in the terms of x and y the same way that I have been talking about, and also we have got the point B represented in the same way of x and y like this. But let us just say A is our first point and B is the second point. So we are going to say the coordinates of the x value of the first point can be given as x1. The y value also y1. The same here x2, the same here y2 for the second point. All right, this is how you're going to denote your point. This is how you're going to represent your points, to say, yes, I'm representing A as my first point. So the x values on A, the x value on A is going to be x1, y1 for the y value. B is my second point. We could have written this in terms of A to say this is the x for the point A, this is the y of the point A, this is the x of the point B, this is the y for the point B. We could have written our points like that. But you can just consider this way to say, this is my first point, this is my second point. Why do you have to consider that? Because it gives us this formula for the distance, which is the length of a line between 2 points and A, B, given that way. It is going to be given by the formula, which is x1 minus x2 squared. All right, so this is the formula that you're going to use. X1 minus, you subtract the x values together, plus you do the same on the y values, y1 minus y2 squared, like this. All right, so what is this formula actually giving us, or what exactly are we talking about here? We are simply subtracting the x values from your first point and the second point, x1 minus x2 squared, y1 minus y2 squared. That is what you're simply saying. All right, that is what we're simply having. So it can be either way. You can even subtract this way. X2 can even subtract x1. Y2 can subtract y1. It's one and the same thing. It's one and the same thing. All right. So with this idea that we're talking about, I want us now to apply it in calculation of the distance that we are given. So this is the length that can be taken from any part that we have. It is just the length of a line. So whenever you are representing or you are talking about the length of a line. All right, whenever you're talking about the length of a line, this is the formula that you're going to use, which is the same as the distance that we have between 2 points, the distance between 2 points. Okay, so we are given here, calculate the length in this case of the line segments in the given diagram. All right, so this is the given diagram. We've got our line segment A, B, then we've got C, D, E, F, and G, H, like that. This is the line segment that we have. So let us start with the A, B that we have here. So remember what I was saying about this formula that we have. In order for us to determine the length of the line AB, we are going to take our formula, and you said our formula is this, that you're going to have x1 minus x2 squared plus a y1 minus y2 squared, like this. What does it actually gives us here is that representing AB, it's up to you to say this is your first point, this is your second point. It's up to you. It's in your hands. The way that you're going to put that way, if you want this to be your first point and this to be your second point, it's up to you. It's in your hands. All right. So in this case, I'm just going to take my A as my first point, then B as my second point. So it means this X value is my X1. This is my Y1. This X value is my X2. This Y value is my Y2. Right? Of which it does not necessarily matter, but you are supposed to take it that way. You are supposed to keep it in mind this way. The way I'm writing, this is the way that you're supposed to put it in your mind. To say our X1, from the first point, our X there is 2 minus 5. So it is going to be 2 minus 5 squared, right? X1 minus X2 squared plus Y1 minus Y2. We're going to take the Y value on our first point, which is 3, minus the Y value on our second point, which is 1. So this is 3 minus 1 squared. This is how you're supposed to have our formula, but that does not matter even if you take it this way to say 5 minus 3 squared, 1 minus 3 squared, 5 minus 2 squared, and 1 minus 3 squared. It does not matter even if you put it that way. All right, so this is you and your calculator. You're just going to need your calculator in your simplification. I advise you to just use a calculator straightforward. And mostly they'll ask you to leave your answer in said form. In said form, it means you are leaving your answer under the square root. Remember, the said form is when you're dealing with the square root, maybe it's the square root of 3, the square root of 10, whatever, but the answer is supposed to be under the square root. So if it is like that, you just need your calculator to simplify everything. That's going to be the square root of, you open the bracket, 2 minus 5 squared. So this is 2 minus 5 squared plus, open the other bracket, that's 3 minus 1 squared. So this is 3 minus 1 squared, like that, which is going to be the square root of 13. So the length of AB is equal to the square root of 13 in said form, which it represents what? The units, the length, just write the units. But if you're asked to give your answer maybe to 2 decimal places, depending with what you're given on that particular question, then you change to 2 decimal places on this part that you're given. Just going to press this SD, check gives us 3.605, which is 3.61. Or you can change this on your calculator, just shift, set up, you fix this 6, then to 2 decimal places, you press 2. Your answer is going to be to 2 decimal places, which is 3.61. So you can also write AB as 3.61 units. You can just even write that way, or you can leave it as the square root of 13. That is, leaving as the square root of 13, we have left our answer in what? In said form. This is said form, okay? So that is it of this question. That is how you can actually be able to calculate the length of any particular or any given line that you have. All you just need is to properly present your points in a manner that you understand them, okay? So I want us to consider this part of CD, okay? C and D. We're going to consider the length of that line CD, okay? So as I said, the length of a line is just going to be taken from the x values. You subtract the x values, x1 minus x2 squared, plus you also subtract the y value is y1 minus y2. So you consider also that we've got the negatives there, does not matter, okay? So C to D, we can take this as our first point and this as our second point. So it means the x value here is going to be our x1, the y value is going to be our y1, the x value here is going to be our x2, the y value is going to be our y2. This is just a presentation. That is my first point, this is my second point, of which it is not of that matter in simplification. All right, so let us just substitute and see what you're going to have. X1, which is the x value here, that is minus 5, to the x value at point D. All right, the x value at C, which is minus 5, like this, minus the x value at point D. The x value at D carries a negative. So it was supposed to be like this, minus 1 squared. This is what you're supposed to have. We have a minus and we have a minus there. So minus and minus, we know that it gives us what? A positive. So instead, we're going to just write as plus 1. All right, so this is minus 5 plus 1 squared. All right, a negative and a negative, minus 5, then minus for the formula. This minus is for the formula. But the x that we are subtracting is already having its negative there. So it's negative, negative, you get what? You get a positive. So it's now negative 5 plus 1, okay? Then the y values will do the same. The y value at point C, it's 1, minus the y value at point D, which is a 4. So this is 1 minus 4 squared, just like that. All right, so everything under the square root, you can determine this, or you can simplify this to have the value of what? Of CD, which is the length of CD in a set form, or it can be to 2 decimal places, depending with the question that you are given for that particular question that you have. All right, so let's just get back our calculator to the normal mode. So it's going to be shift setup. You go to the setup here, then the normal mode, you press 8, then press 2 to get back to the normal mode. It must not write fix unless you want to round off something, all right? So it must not show that fix here on top here, okay? It must not show that. All right, so you've got the square root of minus 5 plus 1 squared. So that's minus this negative in a bracket, minus 5 plus 1, then close the bracket, square it. Then we've got 1 minus 4. So we're going to have plus, open the bracket, that's 1 minus 4. Then you square the bracket, and this is going to give us a 5. So that means this one is giving us the exact value, which is 5 units in that case. So that is the length of the line segment CD. All right, let's move on to the other line, which is E to F. From E to F is just one and the same thing. All right, let me just put it this way so that I do not like erase everything, because I need this formula. Let me just write EF here. We're going to have the same formula, remember? So this is from E to F. So that is from E to point F. So from E to point F, I'm going to consider my point E as my first point, the point F as my second point. So there's no need for me to write x1. I just need to know what I'm doing. All right, I want you to see what I'm trying to say. There's no need for you. You just write, okay, EF is equal to, all right, there's no need for you to write x1, y1. As long you know this is your first point, this is your second point, and you have your formula going to be x1 minus x2. So is the x value of point E, which is your first point, minus the x value there, which is 2. So it is going to be minus 5 minus 2 squared. All right, you do the same thing on the y values. The y value on the first point minus the y value on the second point. So this is the y value. Remember, I said a point is made up of what? Of x followed by y. So the y value here is minus 2 minus y1 minus y2. Already the y here is carrying a negative. It is having a negative. So you write it with a negative. You subtract y2, which is the y value on the second point on our point F, which is the y value there is what? It's a 1. So this is going to be minus 1 squared. So that is it that we have. We've got our point. We've got the length of the line EF, which we can simplify from our calculator direct, like I said, or you can even simplify stage by stage. What am I trying to say? If I'm saying you can simplify -5 minus 2 squared, -2 minus 3 squared, stage by stage, or you can just put everything on the calculator, the square root of. So you're gonna need the square root of -5 in bracket. So open the bracket, negative this one, -5. Then to subtract this one, subtract 2 and square the bracket. All right, so you're going to subtract 2, then you square that bracket. All right, so you're going to square this bracket like this. All right, then let's move on. Plus -2 minus 1. So you're going to open the bracket. All right, plus, sorry. So you're going to need a plus first. Open the bracket. That's -2. -2 like this. Then -1, we are subtracting 1. All right, so that's -2. Then -1. All right, my calculator is a little bit slow. I don't know what's happening here. Then you square this. All right, so this is going to give us the square root of 58. That's the square root of 58. All right, so we are going to obtain the square root of 58 units. All right, which is the length of a line segment, the length of the line EF. Okay, so with this, I think we are just left with this one, and they are negative. Let's just consider the last one because they are negative values, and it's very, very important that we consider these questions that have got negative values, since most of us, we have a challenge when it comes to negative values. All right, so we also have the point HG, all right, or GH, okay, whatever way that you're gonna put this way, HG or GH. So this being my first point, this will be my second point. And also what you have to understand is that the length of CD is the same as the length of DC. The length of CD is equal to the length of DC, all right? The same if I say AB, the length of AB is equal to the length of what? The length of BA. This is length, distance is the same. We are talking about the magnitude of the length, the magnitude, which is always a positive value. All right, so like I said, if I consider this as my first point, then it means my GH is going to be given as the X value, X1 minus X2, that will be X1 minus X here, which is 5. So remember, X followed by Y, X followed by Y. So this is X1, X2, so that's 1 minus 5. So we're going to have 1 minus 5 squared. Then we move on to the Y value. So the Y value, we've got -1, and this is -4. So take note. So you're supposed to have Y, the Y value, the Y1, which is -1 like this. This is the one, this one, -1. Okay. Minus Y2, we are going to subtract the Y2, which is the Y on the other point here. And this Y on the other point, it carries a negative. So it is going to be negative. It was supposed to be -1, -4 like this. So negative, I said it gives us a positive at the end. So this will be -1 plus 4 squared instead of us writing -1 minus 4. Yes, you can do that. These things are to be taken on the calculator. So the calculator does not even respect anything. It works any value. All right, anything. So you can also leave it like that. All right, anyways, let us put these values on our calculator and see what you're going to have at the end on our simplification of the length. So this is going to be the square root of 1 minus 5 squared. So you're going to open the bracket, 1 minus 5 squared like this, then plus, all right, sorry, that's a plus here. So you're going to have plus, open the bracket, -1 plus 4. So this is -1 plus 4, close the bracket, then we square it. So this is going to give us a 5. All right, so here I've got the same length, just like the previous case, which is 5. Remember the previous one, it was a 5. If I'm not mistaken, it was just a whole number, but we are obtaining the same length in that case. All right, so this is how our questions might be given. So we shall see another class that we shall have still on the length, but on the applications of the length. It can be in calculation of the perimeter, the calculation of the area, There are so many things that we can be given on this length that we are talking about. To prove, even for certain shapes, you can be given a question that needs you to prove, or even to calculate for an unknown value, because you can formulate equation. If you're given two lengths which are the same, you can formulate an equation, then you solve that equation depending with the type of equation that you're going to have. So make sure that you catch up the next class so that you'll be able to understand the whole part of this analytical geometry in the application of the length or the distance of a line segment.